electronics and power the digital revolution.
But what no one realized is that someone...
Imagine Earth a few centuries from now. Space travel has become accessible, and we travel from planet to planet in spaceships like regular old taxi.
Welcome back to Science Click. Today, what would we see if we approached the speed of light?
Cabs. But sadly, right now, we wouldn't have enough vacations in our entire lifetime to travel to the neighboring star system. Because to reach the nearest star, Alpha Centauri, which is 4.37 light years away from Earth, we'd have to fly on today's rockets for over 50,000 years. And if we want to get to one of the farthest known stars beyond the Milky Way, called Icarus, we'd need 9 billion light years. This means that even moving at the speed of light will never cross the Milky Way in a human lifetime. That's why NASA is working on types of engines that could potentially be faster than light. But however hard they try, scientists run into new challenges. In this video, along with our engineer, we'll test different types of engines to try and beat the speed of light. However, to do so, we'll have to find a way to bend the laws of physics. But just how catastrophic is this kind of experiment going to be for the universe? How close to the speed of light can we get? In 2017, Norwegian professor Espen Gardar Haug came up with a new mathematical theory. He claimed that it's actually possible to create a spacecraft that, with the help of photons, can accelerate to 99.999% of the speed of light. A photon has no mass, its electric charge is zero, and it can only exist while traveling at the speed of light. Sounds perfect, doesn't it? But if we want to set a spacecraft in motion with photons, we need a new type of engine, one that can convert light into energy. Haug claims that the best way to make this project a reality is a solar sail. So let's try building a sail that moves using light. To make 1 kilogram of matter reach the speed of light, we need a sail with an area of about 100,000 square meters. That'd give us an acceleration of roughly 1 meter per second. This means if our engineer weighs 70 kilograms, they'd have to design a square sail with sides longer than 2.5 kilometers. That's like 25 football fields laid end to end. And that's not even counting the weight of the spacecraft itself. But here's the good news. At least we don't have to worry about designing a fuel tank, since we've got a free and endless source of energy, the sun. It's been burning for around 5 billion years already, and will keep on burning for just as long. The beginning of our solar sail journey might be pretty sluggish, but the acceleration will be constant, and thanks to the sun, we can keep it going for years, even decades. In about 100 days of operation, the solar sail can reach a speed of around 14,000 kilometers per hour. After 3 years, its speed will hit 240,000 kilometers per hour. And then it would only take 5 years to arrive at Pluto, one of the most distant objects in the solar system. This idea of constant acceleration has prompted several research groups in recent years to test increasingly advanced prototypes of photon engines. In 2015, the Japan Aerospace Exploration Agency sent the Light Sail 1 into orbit. Scientists managed to set up a solar sail with an area of 32 square meters on this small satellite. Within a month, the spacecraft, weighing 315 kilograms, had its speed increased by approximately 10 meters per second. Moreover, they were able to change its trajectory. This marked the first successful experiment with a solar sail, though it also shed light on its limitations, as the maneuverability of the design was quite low. To optimize the interaction of the photon engine with light particles, NASA is currently developing what they call a diffractive solar sail. The diffractive solar sailing project uses small optical gratings embedded in the thin sails to make better use of the sunlight. In the future, the photon engine will allow us to travel not just within the solar system, but also to the nearest star systems. However, there is a problem when it comes to interstellar journeys. The sunlight from the sun just won't cut it. The farther the sail is from it, the fewer photons it can capture. In the hopes of solving this problem, an international project called Breakthrough Starshot plans to build 1,000 small solar sails, each weighing no more than 1 gram. These mini sails will require less light to accelerate. Meanwhile, back on Earth, researchers plan to construct an array of laser installations with a power of 100 gigawatts. Their beams will be directed at the mini sails, helping them speed up in space. The destination of this journey will be Proxima Centauri, the closest star to our Sun. Unfortunately, though, it'll take 30 years to accelerate these tiny photon sails to just 20% of the speed of light. Nevertheless, this will let us leave the solar system by 2030 and pass by Proxima Centauri around 2060. But let's imagine for a moment that our engineer managed to push the Starship with the photon sail to, let's say, 90% of the speed of light. What do you think awaits them? Well, of course, new challenges. Firstly, for someone moving at such a great speed, time will tick quite differently. Let's say our engineer embarks on a quick trip to Mars and back. It'll take them roughly 16 minutes 40 seconds to reach the red planet and return to Earth. Now, here's where it gets interesting. For people back on Earth watching our journey to Mars, it will indeed be 16 minutes 40 seconds. But for our engineer in the Starship, the round trip will only last 8 minutes 20 seconds. This happens because at such high speeds, there's a time dilation effect. The closer you get to the speed of light, the more noticeable it becomes. Besides, for our engineer, the space ahead of the ship will appear flattened into a blurry tunnel. After a while, they'll see nothing but darkness up ahead. The thing is, light waves simply won't catch up to them because they'll be moving at the same speed. In other words, there will be nothing but endless darkness before our engineer. So, in theory, scientists already know how to accelerate to the speed of light, but for now, the photon engine doesn't allow us to do that. You see, to achieve the necessary acceleration, we'd need a massive amount of materials to build the sail itself, and an incredible amount of energy to power the lasers required to speed it up. To solve this problem, we'll have to create a more powerful engine that works on a different principle. Scientists have already come up with a theoretical plan for such a device. So, what's stopping us from turning it into reality? Theoretical physicists suggest using an antimatter propulsion system for space travel. It's a concept for a rocket engine that utilizes antimatter in combination with regular matter to generate energy for spaceflight. When these two types of matter react with each other, they can create an enormous amount of energy. It's 300 times more powerful than that of nuclear fusion, 1,000 times greater than that of nuclear decay, and 10 billion times greater than that of ordinary chemical reactions. But here's the rub. Where do we get so much antimatter? After all, it's an extremely rare and complex substance to produce. Creating and storing it requires a colossal amount of energy. That's why engineers have been pondering the development of a hybrid engine to reduce the needed amount of antimatter. One concept of this kind was developed back in 1992 at the University of Pennsylvania, and they called it the Antimatter Catalyzed Microfusion Drive. Its operation revolved around a fuel capsule containing deuterium, tritium, and uranium-238. This capsule was fired into a reactor chamber, where it was first bombarded with ions and then hit with an antiproton beam. When interacting with the antiprotons, part of the matter in the capsule is annihilated. This produces enough energy to trigger the decay of uranium-238, which in turn initiates the fusion reaction with deuterium and tritium. This energy powers big electromagnets that heat up the plasma. Then, magnetic fields direct the plasma flow and shoot it out of the nozzle, creating thrust and setting the spacecraft in motion. The advantage of this system is that it needs relatively little antimatter for space travel. For example, to reach Pluto, you'd only need 100 grams of antimatter. That may sound like a very small amount, but not when it comes to antimatter. The point is, scientists produce it using particle accelerators capable of generating tens of millions of antiprotons per minute. That sounds convincing until you realize that at that rate, it would take tens of billions of years to produce just 1 gram of antimatter. Have you heard of antimatter referred to as the most expensive substance on Earth? It's true. 1 gram of it can cost hundreds or even thousands of trillions of dollars. And it's not just about creating antiparticles. You also need to figure out a way to store them. Since antimatter annihilates upon contact with matter, we clearly can't just put it in a container and call it a day. That's when we need special electromagnetic traps, like for instance, penning traps. These devices, using magnetic fields in a high vacuum and at low temperature, can hold on to antimatter. Currently, portable traps are being developed, and they may later let scientists move the substance to other labs. One such mechanism is being developed at the European Organization for Nuclear Research, but at the moment, it's almost 2 meters long and weighs a ton. Assuming our engineer has enough antimatter, how safe would it be to travel on a starship equipped with an engine like that? Let's say our engineer accelerated the ship beyond the speed of light and is traveling in space without consequences for their body. But don't celebrate just yet, because when trying to stop the ship, our engineer could be killed by radiation. Imagine a photon peacefully cruising through the universe when suddenly our antimatter-powered spacecraft catches up with it. The photon will get stuck right at the front edge of the ship, and when the rocket stops at its destination, all those stuck particles on the front edge will simultaneously release an enormous amount of energy. There will be enough to wipe out not only the ship and its crew, but entire planets. Theoretically, the disaster can be avoided if we slow down a bit before reaching the destination and gradually reduce speed. But even with this approach, there will be intense photon radiation around the ship. Italian physicist Stefano Finazzi from the Italian International School of Advanced Studies and his colleagues explored this problem back in 2009. They found that the thermal flux from the photons directed towards the ship and its crew would be equivalent to a temperature not seen since the Big Bang, 10 to the power of 32 Kelvin, or something like 142 million degrees Celsius. So one journey at the speed of light could endanger entire planets. On top of that, physicists say that a flight on a ship that moves faster than light could destroy the entire universe. How can an antimatter engine destroy the entire universe? In 1994, Mexican physicist Miguel Alcubierre developed a warp drive model. It was a theoretical mechanism for traveling at speeds exceeding the speed of light. The main idea of the warp drive is to bend space-time around the ship in such a way that it's not the starship itself that moves through space, but rather the space moves around it. This means the spaceship won't violate the laws of physics that prevent objects with mass from accelerating to the speed of light. In essence, the ship will stay put. Space, on the other hand, is not bound by this law, so it can move at any speed. But here's the catch. Initial calculations showed that creating a warp bubble would require all the energy that exists in the entire universe. Besides, scientists are concerned that such a bubble could become unstable, especially when entering and exiting warp mode, potentially collapsing along with the ship. But let's assume our engineer managed to build an Alcubierre drive and set off into space faster than the speed of light. And let's assume they even avoided damaging the bubble and successfully regulated his speed to prevent a catastrophic stop. However, there's a problem that's nearly impossible to overcome: paradoxes. Alcubierre himself acknowledges that his drive is essentially a time machine. After all, any method that enables faster-than-light travel also allows time travel. The point is, the warp drive can create closed time-like curves. This means the ship can return to the same point, but at a different time. When our starship goes on a journey, space-time around it compresses. By speeding faster than light, we might end up in a space-time tunnel that throws us thousands of years into the past. This can have truly catastrophic consequences. We're talking about the so-called butterfly effect. The movie, called The Sound of Thunder, vividly shows the dangers of time traveling and how the accidental killing of a single Mesozoic-era butterfly can alter the course of evolution. In any case, to create a superluminal engine without destroying the universe, we'd have to break the fundamental laws of physics. But is that even possible? In 1999, British engineer Roger Scheuer claimed he knew how to outsmart physics. He developed the EM drive, a rocket model that, according to him, could produce thrust without expelling exhaust. The EM drive is a hollow structure with powerful electromagnets inside. According to scientists, electromagnetic radiation bounces around inside the rocket. It travels from the magnets throughout the cavity of the device. And when the radiation accumulates at the narrowest part of the structure, it creates thrust in the engine. In 2016, a team from NASA's EagleWorks laboratories tried to verify if the EM drive idea worked. The scientists claimed they managed to measure thrust. It was a true revolution in the world of physics. However, a team from Dresden Technical University, led by Professor Martin Tajmar, remained skeptical of the experiment's results and decided to try and replicate it. And they couldn't measure any thrust. The thing is, it was absent during the original EagleWorks experiment as well. The phenomenon detected by NASA scientists was a thermal effect. The sensor was simply reacting to the engine's heating. And if our engineer built a ship with such an engine, it wouldn't be able to move in space at all, let alone at some high speed. So in the case of the EM drive, scientists couldn't outsmart the laws of physics. But that's unlikely to stop them. Any space journey beyond the boundaries of the solar system inevitably involves breaking the speed of light. But at the same time, according to Einstein's theory of relativity, that's impossible. The main limitation of our abilities is that as an object's speed increases, its mass also increases and is bound to approach infinity when it reaches the speed of light. Basically speaking, Einstein concluded that the speed of light is the maximum achievable speed in the universe. But modern scientists have come up with ways to potentially bypass the laws of physics and outpace light without actually exceeding it. They suggest creating a space-time tunnel. Let's imagine space-time as a grid. This fabric of space-time gets warped by the gravitational pull of objects. The deformed space-time creates something like tunnels, allowing you to take a shortcut between 2 points known as wormholes. Physicists propose using these wormholes for interstellar travel. Despite the pessimism of some scientists who say that such wormholes could only form at the birth of the universe, others suggest looking for them near supermassive black holes. However, this option is highly risky. Anything that enters a wormhole gets accelerated almost to the speed of light, making any particles inside extremely dangerous for humans. It turns out that even if we manage to build a warp drive starship right now, we might end up destroying the universe. Our attempts to bypass the laws of physics to avoid the end of the world might result in destroying ourselves. So, the question arises, is it even worth trying to outpace light? When we press harder on the gas pedal in a car, we go faster. A car has a maximum speed, but we can accelerate even more. For instance, fighter jets can move faster than the speed of sound. However, acceleration has its limits. No matter how hard we try, we can't go faster than 300,000 kilometers per second. To break through this speed barrier, we'd need an endless supply of energy, which unfortunately we don't have yet. But it's not all doom and gloom. Scientists have uncovered the unknown before, like radio waves and radioactivity. So it's entirely possible that a new discovery will change everything. In your opinion, how many years will it take for scientists to invent a faster-than-light engine? Or will intergalactic travel forever remain just a source of inspiration for sci-fi directors?
Let's embark together on a
I've
spaceship
been using the new
which
ChatGPT
accelerates
5
away
for the
from
last few
Earth.
days. This
moving
will,
faster
starting
and
today,
faster.
become your default ChatGPT from now
What
on,
would we
even if you're a
see when
free user.
constantly
So,
accelerating?
how is it better? Well,
What
the first thing
optical
you'll probably
effects
notice
would
is
occur?
speed. So, this laptop
And if
has
we
the
try
previous
to
model,
exceed light speed
GPT-4
by
loaded up.
bending
This
space-time
has
like in
GPT-5.
sci-fi
How
movies,
many
what would we
rings
see?
does Saturn
Answering
have?
these
Go.
questions will lead us to explore many fascinating phenomena of our
GPT-5 took
universe
3.1 seconds.
and
This
immerse
took
ourselves at the
6.5.
heart
How
of
many
special and
distinct
general relativity.
iPhones has Apple made?
Go.
Oh goodness. Okay. 8.3
Our
seconds.
spacecraft is
11.2
initially at
seconds.
rest.
How many possible
Once launched,
type
we begin to
combinations
accelerate.
exist in Pokemon?
We imagine that its
Not far
propulsion
off.
system
Actually,
allows
quite
us to
far off.
accelerate
This is
constantly
massively overcomplicated
as long as we
5
wish.
seconds.
As we gain speed, we move away from Earth. By accelerating more and more, one would think that the speed would eventually become unbearable. However, this is not the case. Speed has no effect on our body. When two trains cross, it is impossible to feel whether it is our train or the other which is at rest. Similarly, inside the spaceship, we cannot feel its speed, but only its acceleration, the thrust of the reactors which presses us against our seats. If this thrust is reasonable, it will be perfectly bearable all along our journey, even when approaching the speed of light. There is nonetheless a risk associated with very high speeds, a collision. At high velocity, a mere speck of dust would cause colossal damage if it hit us. Fortunately, our ship is equipped with a force field that repels dangerous objects and allows us to roam freely through space. As we accelerate, a first optical effect appears. The stars in front of us, which we get closer to, seem to gradually move away. The sky contracts before us. To understand, think of this common situation. You are in a car driving at high speed, and it starts to rain. The rain falls vertically from top to bottom, but as the car moves forwards, you receive raindrops on the windshield from face on. The rain does not appear to fall from above, but from the front, as if its trajectory were tilted. And the more you accelerate, the more the rain seems to come from face on. In our spaceship, the optical effect is perfectly analogous. The star's light comes from a certain direction, but as we accelerate, the light rays appear to come more and more from the front. Their direction seems different when we are in motion. This is the aberration of light. As light focuses in front of us, its intensity increases, while behind us, the sky seems to widen and becomes darker. The aberration of light results in another strange phenomenon. Let's imagine we are moving through an immense grid representing the fabric of space. Ordinarily, we would see a straight grid made up of straight lines converging in front of us due to perspective. However, by speeding up, the aberration phenomenon distorts the image of the sky around us as the days go by. The grid seems to contract forward and the straight lines bend. If we were to go past an object, it would appear to be slightly angled in our direction. This is called Terrell-Penrose rotation. As we move very quickly, images of objects seem contracted in front of us, and perspective is strongly distorted. We often hear that the further we look into space, the further we look into the past. Indeed, the light we receive from a distant star must travel billions of kilometers. This journey is not instantaneous, and it takes some time for light to reach us. As a result, we see the star as it was in the past when it emitted this light, perhaps several thousand years ago. Who knows how it might have changed since then? Looking out from our spaceship, the same phenomenon is at work. As we move away from Earth, the planet's light takes longer and longer to reach us. If we could zoom in with a telescope, we would see people on Earth evolving in slow motion. This is the Doppler effect. Each tick of the clocks on Earth takes longer and longer to reach us. We receive light rays in slow motion, and their intensity seems to weaken as the image of the planet shifts towards red color. In front of us, it's the opposite effect. The ship catches up with the light, and the stars seem to get brighter. They shift towards blue color, and their clocks seem to tick faster. With precise enough equipment, we could measure the aberration and Doppler effects since the start of our acceleration in space. However, if we decided to end our journey and return to Earth, these effects would have had no impact. They are only optical illusions due to the way we receive light while moving. After several hundred days, however, as the reactors push us ever faster, the ship begins to approach light speed. At such speeds, some phenomena will no longer be mere optical illusions. Real physical effects will kick in with irreversible consequences. Special relativity comes into play. A first consequence of relativity is known as time dilation. Our universe is a huge four-dimensional fabric called space-time, made up of 3 dimensions of space and 1 dimension of time. Inside space-time, all bodies trace a trajectory since they all advance towards their future. Before takeoff, our ship was moving in the same way as Earth towards the future. But by picking up speed and zooming away from Earth faster and faster, our trajectory gradually deviated from that of the planet. The axis we call time is no longer aligned with the time axis of people on Earth. If we decided to turn around and come back, our clocks would have measured a different time, and we would have aged less than Earthlings because our trajectories in space-time would have been different. Another key consequence of special relativity is called length contraction. When a body moves at close to light speed, its length gets contracted in the direction of its motion. From the spaceship's perspective, the entire universe is moving backwards. For us, the universe is contracted along our direction of motion. As such, the length of the journey to reach our destination is shorter than expected. We are not talking about optical effects anymore, but of a physical and concrete phenomenon. If we tried to reach a distant star, the journey would genuinely seem shorter to us. It would take less and less time the faster we move. Thus, contrary to popular misconception, it is in fact possible to travel thousands of light years in just a few seconds. And in the case where we would move almost at light speed, the journey would even seem instantaneous to us. For the people on Earth, however, several thousand years would have passed. Length contraction is a very real phenomenon. However, visually, it would be difficult to see. To understand why, imagine that we cross the orbit of a planet. As it moves very quickly towards us, the planet's length is contracted. But remember, the farther we look into space, the farther we look into the past. And from our perspective, the back of the planet is located further in space than the front of the planet. The image that we receive from the back of the planet has taken longer to reach us, so we see it as it was in the past. Even if it is contracted, the planet does not look like it because we receive the image of its back with a delay. Rather than contracted, it appears to be rotated. This is a phenomenon we have already seen, Terrell-Penrose rotation. When we move very fast and look to our side, the edges of the object around us seem shorter in the direction of motion. This can be interpreted either as length contraction or as a rotation, as a change in perspective. For the same reason, a person watching us zoom by would not really see our ship contracted, but rather rotated on itself. Over time, our field of view continues to contract. It intensifies in front of us while going completely black behind us. By accelerating more and more, we would perhaps expect to reach the speed of light at some point. What would we see then? This question might be one of the most fundamental in relativity. The answer is no. Even if the ship accelerates constantly, we will never reach the speed of light. That is because the speed of light is absolute. You may try to catch a light ray, but from your point of view, it will always escape at the same speed, the speed of light. You may accelerate as much as you wish, even if from Earth you would seem to approach the speed of light. From your point of view, you are still motionless, and light escapes inexorably. In short, it is strictly impossible to exceed or even reach the speed of light. At best, our ship will continue to accelerate forever, and our field of vision will continue to shrink ever more, until forming an infinitely bright spot in front of us, surrounded by a completely black sky. Almost at light speed, all optical effects would become extreme. As we catch up with light rays before us, they all seem to come from the front. Meanwhile, the rays behind us can never reach us. In our frame of reference, the universe would be extremely contracted, like a thin fabric that we would cross from side to side in a fraction of a second. For a person on Earth, we'd be moving at the speed of light. But for us, the trip seems instantaneous. We move infinitely fast. To conclude, nothing can ever move faster than light through space. But there might be a way to circumvent this rule. In fact, nothing prohibits space itself from moving faster than light. Indeed, the theory of general relativity teaches us that the fabric of space-time is dynamic. It can bend in multiple ways. We could thus imagine creating a bubble around our spaceship, which we would propel faster than light. This is called a warp drive in reference to science fiction. it would no longer be a matter of zooming a vehicle through space, but of propelling the fabric of space itself. Our ship would remain motionless, surfing on a wave of faster-than-light space-time. Such a structure may seem absurd, and indeed it is currently thought to be impossible to achieve. Producing a warp drive would require bending space-time with huge amounts of negative mass, a form of matter that does not seem to exist in our universe. That said, mathematics still allow us to model and calculate what we would see in such a situation. If we looked from outside, the warp drive would seem to appear out of nowhere. The curvature of space-time deviates the trajectory of light rays, forming a moving lens which splits into two, one part moving forwards and the other retreating in the opposite direction. Light travels slower than the warp drive itself. When it approaches, light has not yet had the time to reach us. And after it crosses us, we receive both the light which had not yet reached us and the rays which were emitted later. Looking from the inside of the warp drive, we would see the sky contracted in front of us and very bright. Behind us, the universe would look extremely dark, and a whole patch of the sky would simply vanish from our view. The light emitted from there is too slow to catch up with us. A cone of the universe remains permanently invisible. Welcome back to Science Click. Today, what would we see if we fell into a black hole? A black hole is a spherical region of the universe, a sort of space-time bubble which has an intense gravity. This bubble attracts objects as if it were pulling the fabric of space, not unlike a star or a planet. The surface of the bubble is called the horizon of the black hole. It divides the universe into two regions, the exterior and the interior. Below the horizon, the fabric of the universe is pulled so quickly that nothing, not even light, can escape. Today we know that our universe contains many black holes. They are very distant and represent no danger to us. Nonetheless, we can wonder out of curiosity what we might see if we were to fall into one of them. Answering this will allow us to improve our understanding of the extreme phenomena of our universe, and to rectify a few common misconceptions on the subject. Our galaxy, the Milky Way, hosts in its core a supermassive black hole called Sagittarius A star. Using a spaceship, we approach it at a reasonable distance, and we jump into the void of space. Here begins our fall. It will last about 1 hour and will be fatal to us. The spaceship remains stationed, orbiting the black hole and witnessing our fall. Before we even start falling, we run into a problem. The black hole is supermassive. Its gravity equates to a mass millions of times greater than the Sun. With such an attraction, it captures stars and surrounding matter, forming a thick disk of plasma that orbits around it. This disk spins incredibly fast, almost at light speed, and loses energy by friction, causing turbulences that heat it up. It thus produces intense radiations, light, ultraviolets, X-rays and gamma rays, which blind us instantly and risk burning us alive. The plasma itself, which can reach several billion degrees, might also well burn us alive. In what follows, we will therefore assume that we are equipped with an extremely resistant spacesuit, which allows us to withstand the heat and filter out any harmful radiation. However, despite the spacesuit, the disk still seems extremely bright. We can't distinguish anything. We will therefore imagine that our helmet has a visor, which helps reduce the brightness of the disk so that we can observe it in detail, as well as see the stars in the background. At first, we notice that the disk is blue. Within the whole electromagnetic spectrum produced, our visor filters everything but visible light, the light our eyes can see. In this spectrum, the disk emits more blue because this color is more energetic. It is the same effect that gives very hot stars a bluish tint. Strangely, one side of the disk looks brighter than the other. To understand, the matter orbits very quickly, such that on one side it approaches us at high speed, while on the other side it moves away. On one side, the light waves get stacked together, we receive them with greater frequency, while on the other side the light gets stretched, we receive it with less energy. This is called the Doppler effect. It's the same phenomenon that occurs with sound waves when a car crosses the street. Looking at the black hole, we see that the back of the disk appears warped, as if it were folded around the horizon, forming a ring of light. This is due to the strong gravity of the black hole, which deflects light rays, acting like a gravitational lens. Looking in one direction, we observe objects that are actually located elsewhere. Finally, the stars in the background seem ever so slightly blue. We do not feel it, but the black hole distorts time, such that our clock turns slightly slower than that of distant stars. Compared to our clock, the light from the stars seems accelerated, to the extent that we see it bluer than its original color. Surprisingly, during the first 10 minutes of the fall, the black hole appears to be moving away. We are moving closer and closer to it, but its image seems to shrink more and more. Imagine throwing a ball through a car. The ball is thrown at 90 degrees and crosses the car side to side. The passenger sees the ball travel across the car at 90 degrees. But imagine now that the car is moving. This time, the passenger sees the ball coming from the front with a narrower angle. Because the car is moving, objects reaching it seem to come from a different direction, more from the front. In our case, the situation is analogous, only with light rays instead of a ball. We receive the light of the disk from a certain direction, but because we are moving towards the black hole, the rays seem to reach us from a different direction, squashed towards the front. This is called aberration. After these first 10 minutes, we are now falling very quickly, at 4% the speed of light. And from this point onwards, the black hole starts to grow in our field of view. As minutes go by, we gradually descend towards the black hole. Our speed increases and we receive the light in front of us with an increasingly high intensity, while the light behind us seems to get darker. This again is the Doppler effect at play. When falling towards the black hole, we catch up with the light in front of us, while the light behind us has more difficulty reaching us. If we turned around, we would notice that the clock inside the spaceship seems to be running slower than before. The effect is subtle, but still noticeable. This is also due to the Doppler effect. If we imagine that the clock emits a signal each second, these signals take longer and longer to reach us. and we thus observe the ticking in slow motion. Minutes pass, and we gradually fly over the disk of matter. Suddenly, after 57 minutes of falling, the disk seems to fade out. We have just reached the point beyond which matter can no longer orbit the black hole steadily. The gravity is so intense that at this distance, the plasma begins to spiral very quickly into the black hole. Things will now get much faster. Just 2 minutes later, we are twice as close to the horizon. From now on, any light coming from outside is destined to fall into the black hole. This is called the photon sphere. At this precise distance, it's even possible for light to orbit the black hole. As we approach more and more, the passengers who remained in the spaceship see our image fade and gradually slow down until freezing on the horizon. The light that we emit takes more and more time to escape the black hole. It is received increasingly slowly and gradually fades away. The passengers will never see us cross the horizon. But for us, just 24 seconds after crossing the photon sphere, it is time to reach the horizon. After this moment, it will be impossible for us to go back. But what do we see when crossing the horizon? Surprisingly enough, nothing special. It would in fact be very difficult to determine when exactly we cross the horizon. We still receive the light of distant stars, which falls with us. We can still see the spaceship in orbit, in which the clock, even if it seems slowed down, is still ticking. And we can still perfectly see our body, and in particular our feet, because even if all light is carried inwards, it can still move upwards relative to us and thus reach our eyes. This is actually a fundamental principle. On a global scale, space-time is curved by the black hole and generates this horizon inside which objects are disconnected from the outside. But at the local scale, space-time is almost flat and the curvature is not noticeable, which means that everything behaves normally. Furthermore, as opposed to what one might think, the image of the black hole does not appear to encompass us at all. Even if we are now inside the black hole, its image only takes up 15% of our field of view. The rest is still filled with stars. This is again due to the phenomenon of aberration. Now that we move extremely fast, the light that arrives from the sides and even from behind seems to come from the front. Our field of view is contracted ahead of us and widened behind us. In particular, the spaceship behind us seems to grow larger, even though we move away from it. We have crossed the horizon and nothing special has happened. However, from now on, if we try to send a signal to the outside, it will never reach its destination. Below the horizon, everything is destined to fall downwards, with no hope of ever coming out. But for the moment, everything is fine. It is after another 30 seconds, just before reaching the center of the black hole, that in the blink of an eye, we feel an incredibly powerful force that stretches us until dislocating our body. This is called spaghettification. Our head being further from the center than our feet, the difference in pull is such that our body is very quickly torn apart. In our very last moments, we have the impression of falling onto a flat surface, as if we were reaching the surface of an entirely black planet, while a circle of light intensifies all around us. A tenth of a second later, the shredded remains of our body reach the center of the black hole. Our journey ends here, For the moment, modern physics cannot describe what happens this close to the center of a black hole. Our current theories describe singularities, points where the curvature of space-time becomes infinite. But scientists suspect that these singularities do not really exist. We would have to unify gravity with quantum physics if we wish to understand these extreme regions of the cosmos. For now, some hypotheses even question the fact that one could survive crossing the horizon. Moreover, in reality, black holes can have an angular momentum, which generates strange effects with multiple horizons and mathematical instabilities whose consequences we do not yet understand. That said, our current theories still give us a good idea of what we would see. In particular, we can correct a few widespread misconceptions. For example, the disk around a black hole is not orange, but blue. If some images show it as orange, this is because they use false colors, which are only intended to represent luminosity, but not the real color in visible light. Another idea that is widespread is that we would observe the whole history of the universe unfold before our eyes, while our field of view would get engulfed by the black hole. This is also wrong, as it forgets to take into account the Doppler effect and the aberration of light. There are, however, many mysteries left to solve, and we will have to wait until our theories are perfected to understand what truly happens at the heart of a real black hole. Our world is filled with astounding diversity. On ScienceClick, with visual explanation, I introduce Welcome back to ScienceClick.
Scientists are still trying to understand how these form and why they seem to be relatively rare compared to their smaller and larger cousins. But perhaps the most intriguing are the primordial black holes, theoretical objects that may have formed in the very early universe, not from collapsing stars, but from extremely dense regions of matter that existed shortly after the Big Bang. These could range in size from microscopic to stellar mass, and if they exist, they could help explain some of the universe's greatest mysteries, including dark matter. Inside the event horizon lies the singularity, the heart of the black hole, where all the collapsed matter is thought to be concentrated. According to our current understanding of physics, the singularity is a point of infinite density and zero volume, where the curvature of space-time becomes infinite and the laws of physics as we know them simply cease to function. It is a place where mathematics breaks down, where equations produce infinities, and where our deepest theories about the nature of reality encounter their ultimate limit. But here is the truly mind-bending part. Time itself behaves differently near a black hole. As you approach the event horizon, time slows down relative to the outside universe.
This will, starting today, become your default ChatGPT from now on, even if you're a free user. So, how is it better?
It is a measurable...
Well, the first thing you'll probably notice is speed. So, this laptop has the previous model, GPT-4o, loaded up. This has GPT-5.
How many rings does Saturn have? Go! Oh my god.
GPT-5 took 3.1 seconds. This took 6.5.
How many distinct iPhones has Apple made? Go! Oh goodness. Okay. 8.3 seconds, 11.2 seconds. How many possible type combinations exist in Pokemon? Not far off. Actually, quite far off. This has massively overcomplicated it. 5 seconds, 11 seconds. So really, when you're asking light questions like this, GPT-5 is between 30 to 50% faster than the old model. But
I wouldn't really say that speed was one of the key issues before. There's actually a much more important change happening this generation. So if you're a really big user of ChatGPT and you're paying the monthly subscription, it's actually been really freaking confusing to use. Because you open up the app and you have options. You can either pick GPT-4o, O3, O3 Pro, O4 Mini, O4 Mini High, and each one of these models is its own AI that you can talk to. And each one is slightly better than the others at one thing or another. And there's even more than those when you click here to expand. How on earth is any normal consumer supposed to be able to decide which one to use for which question? I have always wondered, if this AI is actually smart enough to be in the top 10% of test takers sitting the most grueling exams on the planet, why can't it also just know what's the best model for your specific question and make the choice for you? Well now, finally, GPT-5 can. This model effectively brings together all the different capabilities of the previously separated specialized models into one general model, which means if you ask it a question that requires no thinking, then as we've seen, it will use a very light model that's going to be even faster than the old one. But it also means that if you then ask a heavier question that would benefit from more thinking, it can now do that thinking without you needing to specifically select a mode designed for it. So let's try something very complex. Make me a game of Tetris that I can play in Canvas. This is going to mean I can actually play it on the app. So I'm doing this first on the old ChatGPT 4o. This is the best model that you'd have had access to before without paying. Still though, easily one of the coolest use cases of an AI. We're approaching 200 lines of code here. And okay, that took 57 seconds. And okay, it's very simple. This is like the most basic possible form of Tetris, but I suppose at the same time I have just entered one sentence and generated a game. So now I want to try the exact same thing, but using O4 Mini High. So this in the previous generation is the model that would have been specifically recommended to you for coding. And you can only get this by paying the monthly subscription. Go. Oh, blimey now, this is significantly faster. It's done already. What? That was 14 seconds. And the game is actually almost identical to what ChatGPT 4o produced, just in quarter of the time. Okay, let's try it on 5. And the thing that I'm curious to see here is, A, does it decide that this is something that would benefit from more thinking time and take longer? And if it does it then make it better? Go. I'd say it's coding slower than O4 Mini High, but still faster than 4o. Okay, that was actually pretty fast too. 19 seconds. Interestingly, more lines of code than both of them. So it seems like it is making a more complex game. That is like worlds apart. So it's the same game, but the pieces now have divides in them. It's giving me a score, it's giving me a level, it's showing me the upcoming piece, there's controls at the bottom. Like, okay, don't get me wrong, none of this is something that you couldn't have achieved using previous ChatGPT models, but it's just the fact that it had the intuition to bake it all in completely unprompted that's quite impressive. Yeah, it's a vastly better game of Tetris. While we're here though, let's just do something crazy. So using O4 Mini High, make me a playable game of chess where the pieces are all Pokemon with sprites from the internet and make it look premium so that the sprites fill up the squares. Go. An error occurred while trying to run your game. It's very cool that you can ask it to fix its own bugs, but in my experience, there's a fairly low success rate. And enter. Loading this time. Error again. Come on, third time lucky. Ah, yes, finally. It doesn't look terrible. I mean, it has gone out and picked up Pokemon images from like the very first games in the 90s. And also it doesn't work. Give me an error message every single time I touch a piece. Same thing in GPT-5. Go. Ah, I rate that. Do you see it specifically said thinking longer for a better answer? And thinking longer it absolutely is. This has taken like 3 times longer than O4. It's actually a little bit crazy just to what extent it's going based on my simple command. Like you can see it coding in like themes and ways to evolve these Pokemon and like seemingly an entirely new rule set that themes chess itself to Pokemon. I'm actually so curious what it's cooked up here. Oh wow. Oh my god. That is a world apart. It's the exact same thing at the Tetris. It's like an implicit understanding of what makes the game look more premium. So if I click a piece, okay, it not only works, but it also highlights all of the legally available moves that you can make with that piece.
tells you whose turn it is at the top here. It is actually just leagues ahead of last gen. Right now, at least, GPT-5 is feeling a lot less like a sidekick that's useful, but only useful in so much as you have the coding knowledge yourself to be able to fix it. But okay, coding is still obviously a bit of a niche use. The thing that I would say is most useful to the most people for AI is just making sure that it's right. Hallucination has been a very real issue with AI. This ability of these chatbots to tell you with full confidence and a straight face something that is actually completely incorrect. And let's be honest, that's not an issue that's suddenly going to be fixed in one generational jump. But they are saying it's better, thanks to a combination of more powerful hardware running this AI, integration of user feedback from the older models, as well as just better ways to benchmark AI, and therefore better ways to identify places in which it's lacking. So put all these things together, it should mean ChatGPT 5 doesn't get things wrong as much. Let me try one that I know ChatGPT used to struggle with, because I was asking it this 2 days ago. Give me 10 tech products made by food brands that I can actually buy. So this is to 4.0. What? McDonald's X T-Mobile phone? I'm very skeptical. This is not a thing. McDonald's did not make a phone with T-Mobile. And then it's got the KFC gaming console, which you definitely can't buy. You see what I mean, right, though? It just invents stuff with complete confidence. Let's see if 5 is any better. I'm a little skeptical. Coca-Cola mini fridge. Okay. Oreo made smart speakers. Did they, though? No, to be honest, GPT-5 is not doing any better of a job than 4 was. It is still inventing stuff, so this still does need work. Here's another one I know that used to really trip up the older AI. What AI are you? It just gives me gobbledygook. What about here? What AI is this? I mean, a much more human-oriented answer. This is ChatGPT with the GPT-5 model. I specifically asked the question in a slightly obtuse way to see if it could still figure out my intentions, and this did. Right, for me, GPT's been pretty good, but also pretty inconsistent when it comes to creative tasks. So I want to give both of these something that is extremely challenging to pull off. Make me a YouTube thumbnail for a Mr. Who's the Boss video titled I tested every Star Wars gadget ever. Off you go. And it's pretty clear why this is such a challenge. It's got to do my face. It's got to understand the YouTube thumbnail image size. It's got to decide what out of all these potential Star Wars gadgets is the most clickable to an average user. Right, so 4.0 first. Second one's not bad. It actually has me holding like a Star Wars blaster and a lightsaber. That's pretty good. I'm just quite cursed, and I don't think those are products you can buy. They're just objects from the universe. Have you done? I would actually say that's worse. It's a little bit less good composition. The text isn't as Star Wars-y, and it's a square. YouTube thumbnails have to be 16 by 9. What if you were planning a 30th birthday party and you want it to be Star Wars themed? How well can these make the invitations? Addressed to Rick, 7 p.m. to 11 p.m. Star Wars formal attire. And go. Oh, this is taking a real long time. That's actually so good. It's Vader in a suit. It's just the right level of sophisticated for a 30-year-old who happens to still be doing a Star Wars party. Maybe you could have cut one of these Star Wars logos, but apart from that, GPT-5's is actually really bland. It just looks like so much less effort has been put into that than 4.0. So it's hard to make a sweeping conclusion based on just a few tests, but one thing's pretty clear, GPT-5 is not a step up when it comes to image generation. But one thing that OpenAI is saying GPT-5 should have for sure is better writing flair, which is actually one of the things I've noticed lacking in the older models. They've always felt a little bit wooden, kind of like they're focusing on getting you an answer as opposed to actually thinking about the delivery of that answer. So how about we do the old how soon will I be jobless test? Write me a 30-second Mr. Who's the Boss tech fail about the Windows Phone. 3, 2, 1, go. Okay, these are actually quite different looking answers. Okay, let's do the 4.0 one, and you gotta tell me how close this gets to feeling like I've made it. You ever hear the phrase, great idea, wrong decade? That was the Windows Phone. In 2010, Microsoft launched a slick, fast, super stable phone OS that nobody wanted. Why? No Instagram, no Snapchat, no YouTube app. Even the calculator felt like a cry for help. They tried paying developers to make apps, didn't work.
They bought Nokia for $7.2 billion to boost hardware sales. Still didn't work. Then they deleted Nokia. By 2017, Windows Phone had just 0.1% market share. Microsoft's official advice: switch to Android or iPhone. To me, that feels about what you'd expect. I feel like it's not quite done the best job of picking the parts of that story that were the most important to tell. Also, the calculator on Windows Phone was actually pretty great, so not at all a reason it failed. The cool thing about this GPT-5 answer is it not just has the script, but it also has notes for how to film it and what B-roll shots we should be using to show each line. So this is the Windows Phone, Microsoft's big attempt to take on iOS and Android. It looked different, it felt different, and it failed spectacularly. Turns out having no apps in 2012 was like opening a restaurant without food. Developers didn't bother, customers didn't care, and Microsoft just gave up. By 2017, the dream was dead, and now the only thing it's good for is being a retro paperweight. Rest in peace, Windows Phone. You tiled too close to the sun. It's good. I'd say still needs work, but that's actually a much better starting point. And it's using analogies in a way that actually makes you think, great point. So, ultimately, GPT-5 is not better at every single thing, but it's still one of those tech launches that's pretty hard to complain about. Like, it's clearly a lot better in a lot of ways. They've integrated all the complexity into one simple model, so they're going to start to phase out the whole this model for coding and this model for reasoning. The monthly subscription is staying the same price, and also you still get access to GPT-5 even if you're not paying. There are a couple of asterisks. If you're not a paying user, then it is capped. You'll get, say, 8 to 10 requests per day using the most powerful GPT-5. And it's looking like when you go beyond that limit, you will then use a less powerful, but still more powerful than last generation GPT-5 Mini.
Six different call centers filled with scammers.
You might receive a notification from our end. Okay?
Maybe. It depends.
And 250 of their accounts shut down.
The internet is working.
My internet's doing pretty good. How's your internet?
And the best
Okay.
part is, these scammers don't even know what happened.
There is something wrong with the system again.
Nothing wrong.
Oh my Jesus! I was telling you, sir. I was telling you, don't do that. Don't do that.
What do you think happened?
What these scammers don't know is that their entire remote control network was just shut down. Any victim that they were talking to, any computer that they had access to, they've lost it. And that call center had 106 active users, so you can imagine their frustration when they realized that they're never going to get it back.
Always secure and fast. Can you see that?
The most important step in a tech support scam is gaining access to a victim's computer. Once they connect, they can hide your screen, access any file that you have on your computer, view your webcam, your bank account, your Facebook page, all without you knowing. They can literally lock your mouse and keyboard and do whatever they want on your computer, and you might not even know. Over the past few weeks, I've seen 6 different scam call centers with 250 accounts using AnyDesk.
Once you have typed in www.anydesk.com,
AnyDesk is one of many remote connection tools that scammers use. Once it's installed on your computer, it can run in the background kind of hidden, and that's important because even if you were to figure out that you were talking to a scammer and hang up the phone before you lost money, if your computer is running, you can still be scammed. This footage is from a scammer who would use phones and computers to sign up for financial accounts. And since they had access to their email, now they could approve transactions and two-factor authentication requests. And these scammers will try everything from PayPal to Apple Pay to signing up for bank accounts in victims' names. It's really invasive and pretty scary if you think about it. I'm used to this because I do this every day, and I have a virtual computer, but a victim would have no idea.
I will help you out how to cancel it. Just follow my words. Open
Okay.
Google Chrome. Just below down, do you see download?
You hear all these guys in the background. AnyDesk has been taking this stuff seriously for a while now, so Jesus. The good news is, these scammers are going to get banned. I want to quickly thank Aura for sponsoring this video today. They provide an excellent service for helping you to keep your identity safe. As you just saw, these scammers will try anything to take advantage of someone. And according to the FTC, in 2021, every 6 seconds, someone was a victim of identity theft. When you sign up for Aura, one of the first things they'll do is show you your credit report and any of your personal information that's been leaked somewhere in a data breach or online. They then monitor your credit and financial accounts and will alert you if something looks suspicious. If someone's using your identity to sign up for bank accounts, you want to know that now, not later. They also have a whole bunch of other tools like parental controls, a VPN, and a password manager, and they're giving Kiboga viewers an exclusive 21-day free trial and up to 42% off. Check out aura.com/Kiboga. Let's get back to the video.
Just leave your computer for a while, sir. Leave your computer, sir.
I'm sorry about that.
Every time the scammer tries to connect to me, that little box behind me, I'm closing out the connection to make him angry and make him think I'm an old guy.
Sir, don't close it, sir. Are you closing something?
Maybe? I'm not 100% sure. Something's popping up I don't recognize.
Okay, don't close it.
I don't know how all this works.
Okay.
Is this you?
Who is you?
Geek Squad?
No, it's not. Yeah, it's me.
Oh, shoot. I closed it
Oh
again.
my god, sir. Why are you doing that, sir? Again and again I told you
so
the same
sorry.
thing and you are canceling it.
Okay, so I got his ID and I'm
And what is the password that you
sending
set
it
it
to
over there?
AnyDesk.
Mother chode.
Easy?
1234 EAS 1234.
The scammer wants me to set a password so he can control my computer whenever he wants, but I'm really just sending his connection ID to AnyDesk's fraud team.
I think I got
Sir,
it.
what you got it, sir?
Easy.
Why did you reject it?
4.
Did you click on dismiss or somewhere else?
Yeah, something keeps popping up.
Okay, I just got confirmation that he's
All
banned.
lowercase?
And they're working on everybody else, so he can't even. He's trying to connect to my computer.
hold
and
on.
I can't now. But it's just funny. He doesn't know what's happening now.
What's going on? I don't see that thing popping up anymore.
Right, because you canceled it so many times. It takes time, sir, okay?
I canceled it too many times?
You canceled it so many times.
Oh, shoot.
Right.
I'm sorry, sir.
I keep
didn't
saying
mean to...
don't cancel, don't do, and you are... Now hold on, sir. There is something wrong with the system again.
Something wrong?
Oh my Jesus. I was telling you, sir. I was telling you don't do that, don't do that.
What do you think happened? Well, I don't want anything to happen. Nothing weird's happening to my computer, right?
We are trying to remove the service from your computer. If you're not letting me remove it, how can I do that?
I tried. I set my password to EG1234.
Right. You denied it. That's the reason why it's taking time. Otherwise,
no.
it's supposed to be done earlier.
Okay, well, can you send it to me again? This time I won't deny it.
Okay, let me send you.
Okay. My apologies. I wouldn't want to do anything that interferes with all you guys working so hard
Don't
to
be
help
sorry.
people. That's the last thing I'd want to do.
Of course, I'm lying. I want them all to be banned, but I don't want them to know that. I purposely didn't say a word to these scammers because every time we would ban them, they would immediately switch to a different IP address, a different network, or a different computer. Okay,
Why
they got
did
a
you
new.
click on
Sometimes they
disconnect? I
switch
told you don't
IPs
give a click on
and
disconnect, sir.
computers,
In
so
that
he
way,
just
you
got a
can
new
cancel
one.
your service by yourself.
That's you that keeps popping up then.
How many
You're saying.
times you are going to apply it, sir? How many times? You are going to be sorry.
I don't know how to do all this.
Don't disconnect it, sir. So don't leave your computer. Just leave your computer as it is, okay? Don't touch your computer anymore, okay? It's me who using your computer right now, okay?
You're on the computer, you said.
Right,
There's
I'm on the computer. So
106
just
of
leave your
them, holy
computer as it is, sir.
They're literally banning 106 of them right now. That's wild, dude. Holy smokes. That second network was a pretty big deal. That's a lot. That's so funny, too. Like, I actually don't want to say anything. So it's kind of funny to,
Hold on.
I prefer, because if I say like, oh dude, I got you, then he knows what's up. If they're gonna keep alternating networks, that's good to know. And now you've got 106 people who don't know what's going on. Whereas if I just say like, I'm hunting you down, bro, then the gig is up. And I feel like it's just better to let them like have no idea. They can't use AnyDesk on any of their IP addresses and any of their hardware. And what's really cool about this is it's not just that they temporarily lose access to whoever's computer that they're currently accessing. It's any computer that they previously accessed. AnyDesk looks kind of like this. Each of these boxes represents a different victim, someone else's family member that they could access at any time. If that computer is on, you click a button and can connect to that computer. When AnyDesk bans their IP and hardware ID, they lose access to this. One of the scammers had 198 different sessions, basically 200 different sessions. And while that doesn't mean they had 200 different computers, let's say it was 10 different computers. Multiply that by 250 scammers, that's 2,500 potential victims' computers safe. And that's huge. I am really proud of that. And I'm glad that AnyDesk stepped up to the plate and did it. Because if I'm honest, there was no like hacking involved as much as I could make this seem like I did a whole lot of crazy technical work. All I did was play the perfect victim. I just became an old man and made it seem like they should scam me. And when I would send an ID to AnyDesk, they did the rest.
Why did you just disconnect it again? Why did you done that?
Oh, is it? I thought you did that. You didn't ask? I thought you told me to do that.
I never told you, sir. Don't be so smart, sir.
You said after a couple, you said if you don't see me moving the mouse to turn it off, I thought. Or did I misunderstand?
I never told you that. I never told you that. You know what you have to do?
There's
you have
no
to be
way
paid.
to cancel it?
Right, I can't cancel.
Oh, no.
Right, because you rejected it, sir. Now the amount
I promise. Heart to God. I'll swear on anything you want. What do you want me to swear on? I promise I won't reject it. I promise I won't. Boy, Scout's honor. I won't click dismiss this time. Please connect and help me.
He can't
Open
connect.
Google Chrome once again. Sir, this is the last time when I'm going to ask you for your ID, and then you can with yourself. You can cancel this service by yourself. Okay?
Sorry, what did you just say? I'm sorry.
I'm not supposed to tell you anything anymore. I'm not accepting your story.
Sir.
You are good. You are good. You son of. You are good. You mother. You son of bitch.
Hey,
Have
I
a great
apologize.
day.
I didn't mean to do it. I'm sorry.
I had some call centers spend hours trying to connect to me on AnyDesk. Imagine 30 or 40 different workers sitting there on the phone with potential victims, completely clueless about what was going on and trying to connect for hours. You'd like to think that a victim would have second thoughts and maybe hang up.
Now just look onto the computer. You see the AnyDesk is there?
40 of their accounts are already banned, but they won't stop trying. He's trying to get on, and I don't think he can.
You might receive a notification from our end. Okay?
Maybe. It depends.
Yes. Just hang on. Now just tell me, is the internet connection is on of yours? Is the internet is working?
My internet's doing pretty good. How's your internet?
Okay. Got the Google app?
They can't use AnyDesk anymore.
The AnyDesk, which is in your computer, right? It is being used from different location as we saw on your system, okay? Now we can't be able to use it because it's been hacked, okay? And that is the reason why we are just using the Ultra Viewer.
Oh, jeez.
No, you got hacked.
Why? If you got hacked, how do I trust you with my security?
No, it's your computer and some other people use your information. Yes.
I'm
so
sorry my computer hacked you. I didn't know.
I'll tell you. That's what I'm helping you out, right?
Piece of the accidental hacker. Oh, jeez.
Sometimes the scammers would get fed up and switch to Ultra Viewer, Team Viewer, or any of the other dozen Screen Connect tools. But other times, they were clueless.
Are you having any connection?
The 2 check mark. That.
You think maybe you're the one having connection problems? I don't think I'm having any connection problems.
No problem. I will try my best, ma'am.
How do you know I got hacked?
Ma'am, because you are saying that you are not authorized by this transaction, so
Yeah, but
might
like,
be
how did
somebody
you
else
find that
trying
out?
to misuse your
Did
personal
you do some
information.
kind of scan to figure that out? Did you accidentally scan your computer instead of mine?
Correct, ma'am. I will go ahead.
I'm not having any
I will
problem.
go ahead and put.
These guys had 3 or 4 different networks, VPNs, phones, and they all got banned.
I'm sure we can make quick work of this too.
Then start broadcast.
Man, you have no idea. I basically spelled it out to you too.
Did you get the request from the PayPal security server? Please accept it.
Have you been trying to do that this whole time?
It's been 55 minutes.
Holy smokes.
Can you please accept the request, ma'am? Because we have to connect with the PayPal security server. If you will not accept it, ma'am, I'm not here to help you, ma'am.
Have you ever played something like World of Warcraft and then someone says, "Oh, well, my dad works at Blizzard. You know, my uncle's gonna ban you," kind of thing. It's like that, except with AnyDesk, and it's real life.
All right.
This entire time, they've been trying to connect with AnyDesk. They can't.
Now, did you get the request from my side,
No,
ma'am?
I didn't get the request. They do not understand. Like, I just have to spell out for him. You have been banned.
What did you see on the screen right now?
You've been banned from AnyDesk. Okay?
So, ma'am, how can we stop the transaction to get debited from your account?
I don't know. Figure it out. But that's not the way to do it.
That's why.
Okay? It's not going to work.
Right now somebody else misused your person.
I know that.
Ma'am, right
but
now.
But AnyDesk isn't going to work no matter how many times you keep trying.
Because, ma'am, you disconnect from your end.
It's not because of me. It's not.
Might be the hacker is doing that.
Maybe
that's why I'm trying to help you out, ma'am.
I'm telling you right now, I guarantee you that you're not going to be able to do that.
Disconnect.
No, it's
ma'am. You disconnect your AnyDesk.
It's because you got banned. Do you understand?
He did not understand, and even I'm getting frustrated at this point.
So, ma'am, first of all,
give me your manager.
Listen to me very.
Give me the manager, please.
Hi, this is Kevin, the senior manager working with the PayPal support team.
Hi, Kevin. How are you doing today?
I'm fine, thank you.
Okay.
Right, I just got the report.
This is not a good look on you.
Yeah.
If you're the manager of these technicians, they really need some help. They don't know what they're doing. It's embarrassing.
Okay.
It's real bad.
Without AnyDesk, it's not possible, miss.
Okay. No, but it's literally, so you're not going to be able to do your job without AnyDesk? Is that what you're saying? That sucks.
Now I just wonder how long they would sit there. I don't even know if they still know what happened. Hopefully, like, they just spend all day calling people and like, all right, so let me connect to your computer now. I obviously didn't show all of the calls because it's hours and hours of content, but I want to thank AnyDesk for stepping up to the plate and actually doing something about these scams. 250 scammer accounts banned across 6 different scam call centers, thousands of victims, computers safe. That's huge. They're shut down, although they're still scamming. And I guess that's the hard part. As exciting as this is, and as big of a deal as this is, unless local authorities and other software providers were to step up like this, these scammers can still be out there scamming. So, hey, if you know somebody who works at TeamViewer or one of these other providers, maybe reach out and let them know that there are scam baiters like me who would happily help them rid their networks of these criminals. I hope you had a chance to laugh and maybe learn something. And as always, know that you're valuable and you matter. Bye. I had an entire scam center convinced that I was an old lady. Maybe because my computer looked like this, or maybe because my face looked like this on the webcam. They claimed hackers were going to steal $94,000 from me, but here's the story of how they had lost $94,000 instead.
Do I have
No, do not open. Just open Internet Explorer. Where you...
What you're about to watch is mostly unedited. I stream these calls live and sometimes spend hours or even days talking to these scammers, and typically on my main channel, I edit that down to say 30 minutes. But this is almost the entire thing. Occasionally, we'll cut out long periods of silence, or if I go to the bathroom or something, we'll cut that out. But for the most part, you're just gonna get the complete full experience as if you were really there when I spent hours talking to this scammer. I hope you enjoy, and if you get a chance, maybe share this with someone who you think will enjoy it as well. Know that you're valuable and that you matter. In the time it takes to watch this video, $3 million will be stolen globally due to scams. I'm Kip Ogo. I've been investigating and educating on scams since 2017. My team and I developed Seraph Secure, the first anti-scam software solely dedicated to protecting people from online scams. Seraph Secure is the hero you need, since 1 in 4 people fall victim to scams. Many online scams start with victims being tricked into downloading remote access software. It allows the scammer to take control of your computer from anywhere in the world, as if they were sitting right in front of it. Even
Our
if you hang up on the
universe,
scammer, you're still in danger
countless
if that remote
eons
access
from
software
now.
is not uninstalled. And what do I mean by danger? Well, the
A
scammers
cold
will have
and
unrestricted
empty
access
place.
to your computer, even when you're not using it. This means your personal documents, photos,
In the
webcam,
emptiness
passwords, even your
sits
bank
a
accounts
solitary
can be accessed
proton,
by the scammers.
the very
With
last
Seraph Secure,
of its
you can
kind.
completely block these scammers from using remote access software, leaving you and your online
This
information
lonely
safe.
proton has lived a long, long time. This aged universe is now 100 billion trillion years old. And so much has happened over this unimaginable stretch of time. Over all these countless years, the cosmos has constantly morphed and evolved. And this last proton has been witness to it all. If the proton could think, then maybe it would lament all that has passed. As it stares into the endless future of untold years ahead. And like an old man facing his own end of days and his ultimate mortality, it might reminisce a little about times gone by. The story of this proton began 100 billion trillion years before.
Anti-heal is useless.
At a time when the universe was young and hot and exciting. The proton was not born at an exact moment, at a precise time that can be pinpointed. And the story of its birth was, unsurprisingly, a little complicated. So let's go back to its birth. Back as far as our physicists can understand our proton's life with their theories of the cosmos. Pushing back to the ultimate creation of our universe has been the goal of a century of physics. But despite all of the efforts of the smartest minds, so much of these initial moments remains a mystery. So our story begins just after the unknown. Just after the very beginning. 1/100th of a millionth of a billionth of a billionth of a second after the moment of creation. At a time when the universe was nothing but fire and light. It is here that we find the ultimate origin of our proton. Where did we come from?
This is my
What is our
IBM vintage laptop.
These days, tech support scammers have a lot of experience connecting to Windows 7, Windows 10 computers. They go through their script and try to sell you things that you don't need for a problem that doesn't exist. But what would happen if they were faced with a Windows 95 computer? Would they even notice what was going on? Or would they just keep going through their script and act like they know everything about technology? For this video, I installed a Windows 95 virtual machine inside of my Windows 10 virtual machine. So I would allow the scammers to connect to my Windows 10 box and then displayed the Windows 95 one for them in full screen. There was no internet connection on the Windows 95 machine, and they're not going to be able to open the run box and type in netstat to trick me into thinking that there's hackers. So we'll see what happens.
Thank you for calling support. This is Chris. How may I assist you today?
Hi, Chris. How are you? Hi. I'm sorry I'm calling so late, but I was on the internet trying to look up a recipe for my Christmas goose. You gotta get it started about a week early, and I'm already behind. And now it's telling me that I have an error. There's an error on my screen.
Okay.
I don't know why. All right. Now what do I do with the computer? I'm looking at all my little avatars that I can collect.
Now you have your. Oh, good.
Well, thank you for helping me, because I would never be able to do this by myself.
No problem. That's why I'm employed.
This is very complicated.
No problem.
I hope they pay you. I hope they pay you very well for this.
Yes, of course. So you click on the run.
Are they paying? They are paying you, right? This isn't like a free service or anything, like community service or something. Did you do something bad?
Yes,
did you get in trouble and now you're doing community service?
No. We are doing it for the paid service. No problem for that. But I was asking that you get a run saved.
Okay.
You got it?
Yeah, I'm not talking to a criminal or anything. Okay, good. It says ID and password. Now.
Right. Tell me your ID. Just give me a moment. So this is the computer that you actually use?
Yeah. Yes. This is my IBM vintage laptop.
All right. Leave your keyboard and mouse to me. Let me go ahead and check it out.
Okay.
Just give me a moment. How old the computer is, miss?
If I had to guess,
How old the computer is?
Maybe 22 years old.
Yeah. Yeah, just give me a moment. Let me check it out. I haven't seen this computer in a while. No matter, I will fix it for free of charge for you. The computer, you gave me an opportunity to check the computer, right? Because it's been a while that I was not seeing this Windows 1. So just give me a moment. Let me check that out, and I will fix it for free of charge, right?
Okay.
All right. So just leave your keyboard and mouse. Let me take it off the rest.
They don't have the virus message, and it's not Windows they're expecting, so they're told to act.
Miss, can you click on the start icon?
Like they're legitimate, because they figure that they're recording and they don't want to get in trouble.
On the computer screen, you have a start. Can you click on that?
Okay.
Yeah, please click on it.
All right.
And then, okay, just give me a moment. Let's click on the settings.
Oh, I think you want me to click on settings for you? You seem to be having a hard time using the mouse.
No, actually, you are using the mouse, right? You leave the computer to me, I will take care of it.
Okay, good luck.
All right. So just leave it to me. Okay, so I can go ahead and fix the computer mess, but it will take 2 hours and there will be charges of $500 to fix the problem. Will that be fine? Because it is a pretty much old computer. We have to reinstall everything. That is older things. That's a Windows computer. So the payments will be high. So there will be a charge of $500. Is that okay for you?
Could you tell me? Could you at least tell me a little bit about what the problem is?
The problem is you've been hacked.
I've been what?
You've been hacked.
I've been hacked, you're saying?
Yes. That's what I'm saying.
Okay, I don't even think I'm connected to the internet.
That's okay. That's okay, miss. No problem. Thank you so much for giving an option to explore the Windows 95 again. Bye-bye.
I don't even know what to say about that one. I thought that he wasn't gonna scam me even a little bit, like even offer to help me. He said he was gonna fix it for free.
Now, you will see option yes. Do you want to make any changes? Just click on yes.
Where is that? Oh, it says secure
What do you see, by the way?
Would like to access
Click
my
on
computer.
OK.
Okay.
Yeah, click on OK. Just allow me a moment. Let me check. Let me check something.
Okay.
Thank you.
This guy's jumping right into it too. The malicious, he's just just run the MRT program. Like, wow, you know? Guess he's just really excited to scam me.
Now, can you please tell me what exactly you were doing on the computer when you got this alert?
There's definitely some.
Definitely something weird happening because he can't do what he wants to do.
Well, I was trying to get my internet mail to figure out. To figure that out.
You're trying to get your internet mail, right?
Yeah.
Okay. And which Windows are you using, ma'am?
The old ones.
Well, but under the system information, it says that it's Microsoft Windows 10.
Is this Windows 10?
That's true because he's technically connected to Windows 10.
Can you close this one? Can you X this untitled notepad?
I'm having trouble controlling my mouse ever since you got here.
Do you remember downloading if your grandson would have downloaded something new on the computer?
He probably did. I let him do whatever he wants on my computer.
Mm-hmm. Well, it seems to be, ma'am, that your computer have got infected with a kind, with a virus or something. And
oh God, really?
That's right. So can you call your grandson and ask him, if he remembered downloading something new from the internet?
All
so
right,
you can restart your computer, ma'am, and shut it down. Get it fixed from a store, okay?
I can see everything
Got
now.
it back? That's wonderful.
As soon as
I would just. Mm-hmm.
It says remote control stopped. Now I can see my old computer. Thank you.
That's wonderful. You're welcome, ma'am.
Well, thank you for fixing it.
Bye-bye.
Merry Christmas.
Bye-bye.
What were you doing exactly? Can you tell me again when you got the problem?
I was trying to figure out my email inbox.
Okay.
My internet mail.
Be online. Let me go ahead and check out the problem. Okay.
All right. How long will that take?
Probably asking his boss, like, "What is this? What do I do? What do I do with this?"
I'm checking. Just be online. Okay.
Also, it's really hard to use the mouse.
Ma'am, are you using your mouse?
No.
Who is using the mouse on your screen?
Are you moving the mouse?
Yeah, I'm not able to do anything.
Hold on. Well, what do you need me to click? Hold on. I can do. My grandson taught me.
Don't do anything. Don't do anything. Don't do anything. Leave it. Don't do anything.
Okay. My grandson taught me how to do this. I have to find the mouse. Oh, mouse. Because sometimes it's very hard to use. You have to go over to here. Here, see if this helps you. Okay? Is that easier?
Leave it. Let me check it.
Okay. I just want to make sure that there's not any more problems on it after I got that message. Because when I restarted the computer, the message wasn't there anymore. But
This is so ridiculous. Why is he on the phone with me still? What is he doing? You think he's just asking his boss what to do? No way is he doing this. No way. Is he typing?
is that you typing?
I was checking the trouble actually.
Okay.
Sorry, my guy, but it's called DOS.
What type of activities usually you do on this computer, ma'am?
He was gonna do it too. He's gonna scam me. Hold on, let me just open it up for him. Maybe
I
he'll
think
go.
on your keyboard, I think you should check your keyboard, ma'am.
I don't know. I think my keyboard's okay. It's a little dusty, but
It's a little dust on your
Sorry,
keyboard. Okay.
I just realized none of
I
his.
checked each and everything. It looks like the computer, as I told you, has already hacked by someone. This is the reason your computer is taking a long time to fix it. So it will take around 1 hour to fix every problem. Okay.
It's not connected to the internet. Oh no! Don't shut it down! Don't shut it down!
All right.
okay. Well, how do I fix it?
I'm going to fix it. There is a one-time charge in order to fix it that is cost you $249.99.
Sorry, say that again. I couldn't quite hear you.
So there's a one-time charge to fix the problem that is $249.99.
And the problem was that my computer is hacked, correct? Sorry.
Yes. Yeah. We have to remove all the hackers, clean everything, and remove all the issues from it. Okay.
Okay. Now, did you
in order
double
to fix, I want your name,
check just
please?
to make sure? Did you double
Yeah.
check that there's a valid internet connection on this machine? Or did you do any basic what kind of diagnosis did you do to find the hackers, out of curiosity?
No, because I have seen, because you are not doing anything on it, and even I am not trying to do, somebody is trying to control on your mouse already. We have to remove these things.
Oh, he hung up on me. I can't believe that. I didn't think that we'd be okay. I did think that eventually we would get somebody that would do this. I thought I would have to try, like maybe 1 out of 10 tries. I guess this shows the scammers don't really care that much about what's actually happening on your computer. They just want to make the sale. I mean, these guys couldn't even go through their script and they kept trying to scam me. I hope you enjoyed this video. Know that you are loved, valuable, and that you matter. This computer might look harmless, but it's infected with dozens of viruses. Mostly meme viruses, but I wrote a custom AI chatbot that interprets every message you write as a program that should open on my computer. So if you type Notepad, it appears. And since thousands of people are typing while I'm live, it's sort of like Russian roulette, except you're holding a gun full of virus bullets and it's pointed at my computer. I'm gonna call a bunch of tech support scammers and see if they can help me fix this disaster of a computer that's controlled by you.
Don't worry, sir. Calm down. Don't worry.
I got. Oh no!
Don't worry.
Sure.
Don't worry, sir.
I got stuff on here I can't lose.
So here's how it works. First, I have to make a bot connect to my Twitch stream and read every single line of chat. Sorry, buddy. Then I filter out all that Zoomer stuff that I don't understand, words like omegalol and kekw. And if there's anything left, an AI model will compare each message to one another. I imagine this is like a big Venn diagram in its brain, and then whatever group has the most votes is normalized and sent over to the computer. My friend Mysterious wrote some code that will search my computer for whatever ungodly things that you typed and will run them.
Sir, it's been around, you can say, 12 years I've been in job in Microsoft.
Wow.
Before that, I was in IBM.
IBM? That's a big company. What were you doing over there?
We were in the fraudulent department of there. If they were receiving any suspicious things or anything on the computer-related stuff, we used to go ahead and check that.
What's the most suspicious activity you've ever cleaned up? If you don't mind me asking.
What kind of suspicious things are going on in a computer, so you can tell me. I will definitely help you out with that.
Well, I got that message, but I also got, there's all kinds of random stuff popping up and going everywhere.
Narrator keyboard.
No issues, sir.
Viewer 6K.
Someone's talking to me now.
Narrator keyboard
Hello?
changes. We've updated the narrator keyboard layout so it more closely matches.
Oh, what did that spook him?
I'm sorry, this mailbox is full.
That was fast. I think the narrator scared him and he blocked my phone number. So now I'm going to call another call center for help.
Don't worry, sir, don't worry. I will be connecting you to our main server, okay? So you don't need to worry right now. You need to be calm down, okay? Because if you will worry so much, then it's not good for your health.
I'm actually feeling really tired right now. You're right. I think I was crying earlier.
Yeah, I understand that, sir.
WordPad window.
It's taken a lot out
So
of me.
why you were crying?
Because, you gotta see what they're doing.
Notepad window. Text editor.
You gotta see what they're doing in this
calm down, sir, okay?
Titled. Notepad window.
Sir, calm down. Your problem will be solved. So you need to be patient and don't cry, okay?
So far, so good. She's not absolutely terrified of the Microsoft narrator, so maybe she can defeat you. Or the virus. Or whatever.
You said they're not going to be able to do anything on my computer anymore? That's what you said?
Yes, because right now I put it the